Hello and welcome back to Ontology Explained. I'm Casey Hart, philosopher and ontologist, and today we're talking LPGs. Not liquefied petroleum gas, or local policy guidance, or low pressure gradient, but labeled property graphs. Alright, let's get straight to it. We're going to start out with the basics. What are they? How do they function? Then we're going to distinguish that from OWL-RDF. Talk about what the benefits are. I throw that in scare quotes because I'm going to sort of emphasize things that people in the LPG industry would prompt as benefits, which I may or may not agree with. And then we'll look at some common LPG platforms for you to get started if you want to kick the tires a little bit. All right, the basics. An LPG looks something like the following. We've got Mario, Peach, and Bowser. We connect them with arrows. Nothing super complicated here. This should be familiar if you've been on this channel for a little bit. We've got nodes and edges. So nodes are those circles, right? They're entities. They stand for things that we want to represent in the world or in our data. And then we've got edges, and those are our arrows. Those are the things that directionally connect our different entities, our different nodes, one to another. So Mario loves Peach, and Peach is captured by Bowser, and Bowser dislikes Mario, who dislikes him back. Now, why are they labeled property graphs? Well, these things can have labels. So on Mario, you've got that sort of person label on it. Same for Peach. Bowser is labeled as a Koopa. For properties, for the edges, the labels are just the names of the labels, which is a little weird, right? The name of the Mario node is Mario. That's not its label, that's its name. Its label is person. Whereas the dislikes arrow, it's labeled dislikes. Under the covers, when it's sort of being represented in an LPG, they'll have unique identifiers for them, which are distinct from those labels and those names, but that gets us too much into the weeds. Don't worry about that too much for this video. All right, properties. So a labeled property graph, again, we've seen the labels, we've seen the nodes and edges that make it a graph, but what are the properties? These get hung off of our edges or our nodes, and essentially they're kind of like JSON blobs. If we want to say things about Mario, right? His name is Mario, his age is 44. So these nodes have key value pairs that get stuck onto them. That's the property bit. You can think of them almost like data type properties in an OWL-RDF structure. A really helpful place to go if you want to play around with building a labeled property graph and see what it feels like, what it looks like, is Neo4j's Arrows app. Here's a link to it. I'll drop it down in the description and we'll go to it in just a second and look at an example. It's put together by Neo4j Labs. I'm not sponsored by them. If Neo4j would like to sponsor this channel, reach out to me. But I find the app super useful, even if you're not planning on doing anything with LPGs and you want to build an OWL-RDF graph, or heck, you just want to build a directional graph, sort of sketch some stuff out. The app is pretty slick. You can save it to your Google Drive and play around with stuff. So worth taking a look at. Okay, so here you can see the picture, the graph that I had on the last couple of slides. We've got all the nodes. And if you want to create some new nodes, right, you can just drag away from this. Let's say I want to put Yoshi up there. Great. And then I can label Yoshi. He's got this label here. He is a dinosaur. This is where maybe my Mario knowledge will get me in trouble, right? And then we can name this edge. I usually start them with a colon, although if you don't, it's totally fine. I think it puts it in as part of the Cypher query generation, which I'll show in a second anyway. And say that he, I don't know, rides Yoshi or something like that. And then if we want to say when he rode Yoshi, right, then we can add some properties here, right, that has like some time. And so this is what we were saying earlier. The properties can get hung off of either the node or they can get hung off of our edges as well. Super fun way to play around with this. You can change the node colors. And I've done this for a couple of different clients. It's a nice way to mock something up really quickly. I even mock up Ontology for OWL-RDF if I'm going to build something. It's kind of a handy way to see what it's going to look like. Pretty good for visualizations too if you want to drop something on slides, as I've done in this YouTube video. Good resource to look at. If you take nothing else from this video and you're an OWL-RDF person, take a look at arrows.app and see if that does something useful for you. So now that you have a feel for what LPGs look like, how does that stack up against OWL-RDF, which you're more familiar with if you spent a little bit of time on this channel? If you haven't, take a look at some of my other videos and learn what OWL-RDF looks like. If you are trying to draw the same picture, right? If you want to make the same description of Bowser and Peach and Mario in an OWL-RDF ontology, we're going to have to formally define what our various classes are, like person and Koopa. Whereas in LPGs, we're just going to throw those informally on as labels on each of our nodes. Similarly, properties, we're going to have a more formal definition in OWL-RDF. We're going to say what's the domain and range of these things. Whereas in LPGs, your properties are hooked on as those sort of key value pairs that attach to each node or edge that you want to say any properties about. And really what both of the difference between the formal semantics that goes on in an OWL-RDF ontology versus LPGs are that LPGs are interested in representing your data, getting your data in, whereas OWL-RDF ontologies are mostly focused on setting up a semantics, a meaning of your data, and then putting your data within that vocabulary and that framework. Of course, you can do both with either of these, so I don't want to lean too much one way or the other. You can build an LPG with a really heavy formal semantics and ontology as part of it. You can also do a cheap, just get the data in to an OWL-RDF model and not do the formal definitions. But I would say that in general, people who are building OWL-RDF ontologies are thinking about semantics a lot more. People who are building LPGs are thinking get the data in a lot more. And the people who build the tooling for these respect those different preferences. So you're going to find, if you find yourself drawn to one or the other of those preferences, maybe that will guide you towards LPGs versus OWL-RDF. If you want to write queries against OWL-RDF, do them in Sparkle. If you want to do it in LPGs, it depends on who's hosting it, but Gremlin or Cypher. And then if you want to enforce the schema or do data validation, there are ways to do that with both of those. So it's going to be stronger, I think, OWL-RDF, less strong in LPG structures. And to just hammer this home one more time, let's take a quick look at what a representation in Turtle would look like for the Mario Bowser Peach bit versus what the Cypher query that's going to generate that in a Neo4j graph. So you can see we have a Turtle file here. And if we want to say things about Princess Peach and Mario, like Princess Peach is a human and that she's captured by Bowser, well, we need to define what a human is, right? So we're going to need to represent human, the class, and that's a subclass of person, just like Koopa, and person is a subclass of animal, etc., right? So we're thinking about what is our overall vocabulary, how do we tie these things together, what's our subset relationship between classes, and we don't just say that she's captured by Bowser. We need to have a property definition. What does it mean to have captured by? So that's an object property that relates one animal to another animal. I should probably do even more work on this, right? I certainly want to have comments and descriptions of what this looks like. But even at just a first pass, I need to define the property and say what it is. Contrast that with what a Cypher query looks like to create the same stuff that we've got in Turtle above here. Well, we're just creating the three nodes. We're creating Mario and Bowser and Peach. We're relating them by the edges, and that's pretty much it. Now, again, like I said a few seconds ago, yes, you could create a more robust ontology and define what these various labels are, like person as a label. You could create a new node that stands for that. But then you're already doing slightly hacky things that LPGs aren't particularly designed for. You're trying to sneak more semantics into it than naturally fit in a Neo4j model. Not impossible, and to be totally honest, I do some hacky things to get a little more, pragmatic features into OWL-RDF. So we all sort of work with the tool set that we have. But again, that gives you the flavor of which direction you're leaning. Get data in quickly. We're thinking more LPGs. Have a more robust model that the data fits into. Then we're thinking more OWL-RDF. At least that's the tilt of things. So we've got LPGs. We've got OWL-RDF graphs. What are the benefits? Why should I go for LPG if I'm interested in it? And again, quotes around benefits, because I think some of these are a little bit bogus or overstated. But if you ask someone in the industry, or if you go read Neo4j's website and some other things to say, okay, what do LPGs get me? This is what's going to come up again and again. First and foremost, LPGs are simple. They get your data in, you can see the graph, they build tooling that's sort of a drag and drop kind of thing. That feels nice. OWLRDF has a little more academic vibe to it, maybe a little more difficult to construct things. This comes up a lot too, that LPGs are better at handling many-to-many relationships. I think this is false, and I'm actually going to do another follow-up video on this, but I've seen this claim in a number of places, so we'll circle back to that. But because of the first class entity that properties have in LPGs, where you can stick properties on top of them, it makes them a little more amenable to doing certain things than OWLRDF. You absolutely can do them, and in fact, I like the OWLRDF semantics and structure better than I like LPGs, but this is something that all LPG advocates are going to point to as a real advantage. LPGs are also more modern. The architecture that they're built for tends to run a little bit faster, and it's more recent. So if you like newer things, something to be said for LPGs on that front. And the biggest feature that comes along with that, and this I really do think is an advantage of LPGs, if you have a ton of data and you need to be able to query it very quickly, especially through pattern matching structures, LPGs are going to be better suited to that. Okay, I've mentioned a couple of these, but the common LPG data platforms, we've got Neo4j, ArrangoDB, JanusGraph, and NebulaGraph. There are some others out there. I spent a little while searching around to see what rises to the top. Those four I've seen more than just about everything else. That doesn't mean there aren't other good competitors out there. Apologies if I've missed something. If you advocate for one or have played around with one, you have thoughts about them, feel free to drop them in the comments below. I'd love to learn more about them. Like I said, I've built a few LPG graphs, not as much my cup of tea, but I'm always happy to learn more. So if there's a company out there that you'd really advise or a platform that you think works really well, I'd love to know about it. Most importantly, go do your own research, right? Go out there, take a free trial with these, try drawing something, write some queries. There's some other YouTube videos out there, especially for Neo4j. There's actually a fair amount of tutorial videos. Go play around with it a little bit, see what you think. Okay, in summary, labeled property graphs focus on efficient storing of data, and that data consists of labeled nodes and edges that have key value paired properties that hang off of them. Most common data platforms, Neo4j, ArrangoDB, JanusGraph, and LPGs emphasize speed and pattern matching over semantics. Not saying that as a value judgment, that's just how it is. Okay, I will, however, do some value judgments coming up in the future. This video is just to introduce you to the topic. If you want me to be mean and angry about LPGs, like and subscribe to the channel. We will hit some of those soon. Stay tuned. Bye, everybody.